Today we're going to be taking our areas and we're going to revolving about a line. So let's say we're revolving about this line. I'm going to call it y equals c, and I'm going to change my intersection points from A to B. So I'm revolving around a horizontal line, so that's like revolving around my x-axis. So everything has to be in terms of x. Don't forget your pi. So pi integral from A to B, and I want you to think about it like this. The outer radius squared minus the inner radius squared, and in this case everything's with respect to x. So in this case, I'm just getting my setup ready. Our outer radius is the line and then our function. So the line minus the function, because this area would technically be negative and I need to make it positive. So line minus our function. And then our inner radius is the whole line minus these function value. So again, line minus our function value. Now this is if everything was in terms of x. Okay, you're revolving around a y equals line. If you're revolving around an x equals line, everything needs to be in terms of y. So your a and b values are going to be y values, and your equations all need to be in terms of y. Our first example, we have the volume of the solid generated by revolving y equals 4 root x, y equals 8, and x equals 0. So let's get an idea of what that looks like. This is a radical function. Y equals 8 is a straight horizontal line, finding where they intersect. We know the y value is 8, so plug in y equals 8, divide by 4, and square everything, and we get 4. So I'm taking this area here, and I'm revolving this around the line y equals 8. So I'm taking it and I'm revolving it around that line. So this is what my radius is going to be. This line is this example is nice because our area butts up right to our line. So we don't have two radii to deal with. We don't have an outer and an inner. We just have one. First thing, don't forget your pi. I often forgot that. I had to restart recording this video because I was forgetting my pi a lot. Okay, so, and then don't forget to square it. Another reason I had to restart. Since it's a straight horizontal line, it's like revolving around the x-axis, so everything's in terms of x. So we need to figure out the length of this radius. Well, the length of that radius is the line minus the function. So this value is the line 8 minus the function. Now, I don't know if you're ever going to see these. You might just see the setup on a non-calculator piece of the AP, but I don't think I've ever seen it where it is on, where you have to actually multiply all this out. For MyMathLab, you'd have to multiply all that out. But I'm okay if you guys just plug this now in your calculator and get me the final answer. And I use my calculator, I'm not going to lie to you. Next example, so we have the same area, so I'm going to get myself a sketch of this same area. But now we're revolving around the line x equals 4. So we're revolving around this line. In this case, our area doesn't butt up right next to it. So we have to remember to do pi integral of the outer radius squared minus the inner radius squared. And since you're multiplying around an x equals line, everything needs to be in terms of y. So my integral values that I'm integrating with respect to are from 0 to 8, because I'm integrating with respect to y in this case. So I need to take my outer radius minus the inner radius to get my resulting value. So our outer function in this case is just our line squared minus the inner radius. Now the inner radius is going to be the line minus the function. But our function needs to be in terms of y. I need to solve this for x. So I divide by 4, and then I square both sides. So that function goes there. Everything is in terms of y. Again, I would just plug this in your calculator. When I plugged it in my calculator, and I see a lot of eraser marks here in my notes, so you know I went about it a really long way and made a lot of mistakes. When I did it by hand, 896 pi all over 15. And again, you can always be giving me the decimal approximations of that. That's fine, as long as we are correct to 3 decimal places. Okay, our next example. Find the volume of the solid generated by these two functions revolving around y equals 4. Sketch yourself an idea of what the graph looks like. Y equals x squared looks something like this. Y equals 2x. Y-intercept of 0 looks something like this, and y equals 4. Well, first let's find that intersection point. So I set the two functions equal. I subtract the 2x over, and then I factor. So y of x equals 0, and x equals 2. So this intersection is 2, and the y-coordinate is 4. So I know that my line, so this is the area we're revolving around the line, let's put it in green, y equals 4. Again, our area doesn't butt up right to the line, so I need to do outer radius minus the inner radius. So pi outer radius squared minus inner radius squared with respect to x. Everything is in terms of x, so my x values for integration are 0 to 2. Okay, so the outer radius, this piece right here, is the whole line minus the function x squared. So I have 4 minus x squared. And then the inner radius is 4 minus 2x. And as I've said before, you can just put this in your calculator. 32 pi over 5. Okay, last example. Find the volume solid generated around x equals 6. So let's get an idea again of what our curve looks like. X equals y squared is a parabola hanging out on its side. X equals 4, 1, 2, 3, 4. So I'm rotating, let's do this not in black because that would look really gross. We're going to revolve that area around the line x equals 6. So this point down here is for -2. This point up here is for 2. So pi outer radius squared minus inner radius squared. Since I'm revolving around an x equals, everything's in terms of y because it's like revolving around a y-axis. Okay, so my integral values for y are the y values that bound the area, -2 to 2. Now we need to do outer radius, so whole line minus the function, whole line minus the function, minus the inner radius, which in this case actually it's kind of nice, is line minus the other line, which is 4. And again, doing this in our calculator, we get 384 pi over 5. Okay, that is all I have for you guys for today. Please make sure that your lesson summary is submitted on time.